Hi, in this video I'm gonna be showing you how I created a Python script for fixing hierarchical material files used in DAZ Studio. If you didn't watch part 1, I recommend watching it first because it explains the reasoning behind the script. In this part I will show you how I did some preparations and begin the script, read files from a directory, get command line parameters, handle exceptions, parse a path from the Windows Clipboard, create functions, use Globbing for file filtering, terminate with exit codes, create conditional branches and loops, find out if a file is GZip compressed, read from files in different modes, and load a JSON file. Remember, I want to remove the Genesis 9 node and the here node's reference to the parent node for all DOF files which are hierarchical material assets. If you know DAZ Studio well enough, you might now scream at me, why for heavens Python? Fair enough, since DAZ Studio's script engine is QtScript, which is closely related to JavaScript, but there is a simple reasoning behind it. I'm just way more familiar with Python than I'm with JavaScript, and everything I need for my task is independent from DAZ Studio, so no need to stretch myself. If you're adventurous enough to play along, you should go to the official page of Visual Studio Code, search for Getting Started and follow the instructions there. And for those of you starting to throw Microsoft fanboy at me, VS Code is just one IDE of many others. JetBrains PyCharm is also an excellent environment that offers a free community edition, just to name one of them. I've Python installed, VS Code installed, and within I got the Python extensions from the marketplace. Everything I show you is freely available at no extra costs. I start with creating a folder for my little project and name it Hierarchical Material Corrector, or at least an abbreviation of that. I open the context menu for this folder and start VS Code. That way it will automatically set the project folder there. And yes, I trust myself, thank you. In my project folder, I create a new file called hmc.py. I choose a short name here because I potentially have to type this in the Windows command line. Because I gave my file the extension .py, VS Code knows that it is a Python file, and while I'm typing it comes up with a lot of suggestions, all based on the programming language Python and the code I've typed so far. To try it out, I go for the most famous Hello World example. To test it, I open the bottom panel where the Terminal aka command line interface is. And there I start my little program by typing py for the Python interpreter and hmc.py to tell the interpreter it should execute my program. And it worked. How nice. Some installations of Python do not automatically map the shortcut py, so you might have to write out Python. And as a third option I want to mention the play button, which automatically uses fully specified paths. Okay, so Python works. Let's start them. Before I go on, I want to make it clear that this is not a comprehensive Python course. It just shows you to perform a particular task with Python. But I strongly encourage you to play along. You're gonna be surprised how much you can learn from solving such a simple problem. So what does my program have to do? Let's outline some cornerstones. First, it must know which files to read. These are the ones in the material folder of the product. Then it must read the material file's content, whether it's compressed or uncompressed. Once it got the content, it must remove the Genesis 9 scene node and also the reference in the material node. And lastly, it must save the result back, preferably in the same format it read it in. I'll keep these comments in my code as a guideline. I get the list of files in a directory using a function in Python's OS module, which I have to import first. If I type OS, VS Code helps me by offering a code action which is behind this little light bulb. I add import OS to my program's import section, which is by convention at the beginning of the file. Even standard Python offers thousands of functions and methods which are organized in packages and modules. A few I can use without an import, but many more I must import to tell the interpreter where to look in Python's vast library. Also note that my editor tells me that OS is a known module by coloring it green. Functions and submodules are delimited by the dot operator. As soon as I enter a dot after something known to the editor, it makes proposals. I'm gonna use the list_dir function in the OS module to get my list of files. Now the editor tells me that in the function argument, I can specify the path to the directory I want to get the files from. None means that I can also leave it empty. The return data type will be a list of strings. And this list I can print out. If I run my little program, I get one entry, and that happens to be the program itself. That is because I did not specify a path, so the interpreter takes the path in which my program was started. If I add another file to my folder, let's call it dummy.txt, I will see 2 entries in the list. To make this working for my purpose, I must copy my program into the Materials folder and execute it there. This time I'm using the command line window for starting the script. And executing it inside the Materials folder, I get a long list with all the files in it. That's nice, but very inconvenient. I want to leave my script in the Tools folder and tell it where it has to search. The command line call could look like this. The text in the brackets is called command line argument, and I can access arguments the user entered within my Python code. What I need is in the sys module and is called argv. This is not a function but a list, and I can access the elements in the list with square brackets. The element 0 is the command itself, so my folder argument would be 1. And of course I can print that. Try it out, and oops, the angle brackets are not allowed in command line arguments. But now it works. The error I get this time is intended, because there is really no such folder. Next I have to feed the argument 1 into the list_dir command, and as a result I get the list of the directory I specified when calling hmc.py. Note that I must put the argument in quote marks because it contains spaces. My previous attempt without those did not work. With the introduction of arguments, the script lost the ability to run without an argument. Here you see that I can't access a list element which does not exist. To make the script more flexible, I encapsulate the line accessing the argument list in a try except block. The try keyword tells the interpreter to execute the except block if any code within the try block fails with an exception. Following the except statement is a reference to the type of error which the except block must handle. If a different error occurs in the try block, it's still an unhandled exception which causes our program to end. You surely noticed the indentation in the try and except block. This is specific to Python, in which you build structural blocks with 4 spaces, opposed to other languages like JavaScript, Java or C and the likes, where it's curly brackets. This is a caveat for many Python noobs and much hated by people used to those other languages. Thankfully, modern IDEs help with features like auto-indentation or auto-tab replacement. Since the except block is my alternative if I don't provide an argument, I still must assign something to the mat_path variable, and this something is the current path we are in. If I execute my script without an argument, I get the one file in the current directory, like before, and also the other method with the argument still works. So my little script offers 2 ways to be operated so far, but the most likely way, I'll call it, is yet to be implemented. Whenever I select an asset in one of DAZ Studio's content panes, it shows some information for that asset in the pane's info tab. Here I can see the path to the asset file, which is a link. The link's context menu allows me to copy the path to the Windows Clipboard. So I want my script to additionally read the clipboard content if the other methods fail. First, I define a constant containing the base path to the DAZ content. Whatever path my program has to deal with, if it's not starting with this base path, it's not gonna work. The R is the raw string literal and suppresses the processing of escape sequences the backslashes in the path would trigger. If my path after reading it from the command line does not start with the DAZ path, I must get it from the clipboard. There are many ways to read from the Windows Clipboard, and I decide for the module tkinter, which is actually providing a user interface for Python, but its clipboard functions are very easy to use. Testing my code, I get an error. That is because the string DAZ Studio puts into the clipboard starts with file, which would tell the File Explorer to load a file if I'd insert it there. To fix this, I'm using the function URL parse from the module urllib. This function will split the given string into its components if it complies with the rules of URLs. I am particularly interested in the component path, and maybe scheme could also be useful. Let's try this out. My material file path is the parsed clipboard content, and that I print. I temporarily add an exit call because the rest of my program is not ready yet. In the result object, I see that the scheme entry is the string file and the path entry is my desired path. However, the path refers to a distinct file, while I need just the folder. First, I'm accessing only the path attribute of my URL parse object. Then I get only the paths folder component. A quick test confirms that mat_path seems to be the correct folder string, but a test including my listdir function reveals that I'm not quite there yet. Listdir doesn't like a backslash left to the drive name, so I need to add Python's built-in string function lstrip and tell it to cut the backslashes on the left side. And this time I get my folder content again. Now that my code is growing, it's time to organize it in a better way. I encapsulate parts of the code in functional blocks. In Python, functions are defined using the def keyword followed by the name of the function and a parenthesis for the arguments. My function does not need parameters, so I leave them empty. The purpose of my function is determining the path stored in the clipboard, so it will have a return value. I can handle a path as a string, and so I add a type hint that my function returns a string. Python is a dynamically typed language. We do not need to specify a type when declaring variables, but it's good practice to do so in assorted places. Type hints do not get processed by the interpreter, but they do have an influence on the behavior of VS Code and other IDEs providing static type checking. I copy the code that retrieves and processes the clipboard content into my new function. Since this is a code block structure, I must get the indentation right. My function ends where the indentation ends. My function determines a string, and I must make sure that this string gets returned to the caller. Finally, I must call the function from my main code. If I start my program, the interpreter will start at the top and import all the specified modules. It will assign the constant and then quickly jump over the function, since this only needs to be executed once I call it. It will try to get the arguments and fail because there are none, and store the current path in mat_path. Being empty, it does not match my valid start path, so it reaches the function call. Seeing that, the interpreter jumps to the function and executes the code in it. Next, the interpreter returns to the place from where the function was called and assigns the value to mat_path. The rest is trivial. Next, I make clear where my main section starts because I will need many more functions. And doing some cleanup. I now get a file list, but it's not very good. It lists all the files, but I'm interested only in DUF files, so I gotta filter the list, or even better, use globbing in the first place. What's globbing? Well, a glob pattern allows to specify file names with wildcard characters. It's around since the first Unix days, and so it's ancient in terms of software development. DOS had it from the first hour on, go figure. And of course it's being supported by Python. Let's import it and use it instead of my listdir command in line 27. I build a material path with my wildcard by using the join function and feed it into the glob function, which will return a list of matching files. I try to avoid defining patterns in the middle of my code, so I use an extra constant for this. After trying it out, I see a lot of paths to only DUF files in my list. For the case my clipboard contains not a path but something else, I need to add an error handling. The script would then exit with error code 1. The way I use my script, most likely I don't need exit codes, but if the script was called by other scripts in a bigger automation context, for example, the caller would be informed if something went wrong. I can try that out by using the Windows command line. Here I started the script with nothing in the clipboard and I get the error message. And with the echo command, I can print the exit code the script returned. I didn't talk about the conditional branch we introduced by using the if keyword. Well, there's not much to say about. Of course, Python has if, else and elif constructions and they are used like in many other languages. They decide to execute code based on a Boolean expression. Noteworthy is that 0, none and empty iterables like lists are interpreted as false. And of course the conditional code builds a block which needs the right indentation. The third basic building structure we need in our program is the iteration, i.e. loops for repeating code. The glob function in line 32 returns a list, and with the for statement I can iterate over the elements in the list. With each repetition of the code block within the for loop, the variable duf_file will have one value of a list element. And of course I must tell the interpreter what belongs to the loop, which I do, you guessed it, with an indentation. After the for loop worked through all elements, the interpreter continues executing code after the indentation. I test my code and see that I get a nice listing of the DOF files in the materials folder. The list is nice because the print function gets called for each element in the list separately, instead once for the whole list. Print adds a new line at the end of the string automatically. For the further development, I add a break statement to the for loop. Break will exit the loop no matter what state it is in. Normally you use it in a conditional branch. At this level it would exit the loop in any case during the first iteration. I do that because I do not want my half-finished code to be executed many times. If you're eagle-eyed, you might have observed that I already removed one to-do from our list, and my next task is to read compressed and uncompressed files. Let's refine this to first find out if it's compressed, second load it and if it's compressed, uncompress it, third find out if it's a materials file, because if it's not, we gotta discard it. So my next task is to write code that finds out whether my file is readable like this or a gibberish like this. How can I do this? Now, I could try and find a recognizable word in the file, because the gibberish is very unlikely to have any human-readable word in it. It would work in our case because we are only considering DUF files and these are always JSON-like. But there is a more general way to determine compression, a more scientific way if you so will. Ever heard of magic numbers? No? Then it's time for it. To find the magic number, we must know which type of compression DAZ Studio uses, because there are many different ones of them. Finding out something like that is an ordeal, because DAZ documentation is crap and no one cares. Here is a hint that's GZip, and in some forum thread people are discussing compression as well. So you need to humbly ask rather than read it in a proper documentation. Anyways, now that we know that's GZip, we can have a glimpse into their documentation. And that's no honey licking either, for it refers to an RFC in which they tell you about the structure of a GZip file. Look how old this already is. If we scroll down, we learn that a GZip file has a header, and that the header starts with 2 identifier bytes, and that in a GZip file those 2 bytes always represent the decimal value 31, which is 1F in hex code for the first byte, and 139, which is 8B in hex for the second byte. And that, folks, is our magic number. I admit we could have had it much easier by just Googling it. Or simply look it up in Wikipedia, but then I would have missed the opportunity to show you the original information in an official document. So these puny symbols at the very start of the compressed file tell me that's actually GZip. Are they really 1F8B in hex? For this to check, you've got to have a hex editor extension like I do. If I then open the tab's context menu and select Reopen Editor With, I get the option Hex Editor, which makes the DOF file look like that. On the right column section I see the hex codes, and lo and behold, it's 1F8B right at the start. So there's one final theoretical question left. Can a JSON file also start with 1F8B so that my code would erroneously detect the GZip? No, because the JSON specification tells us that it's organized in objects and arrays, which either start with a curly bracket or a square bracket. And to those screaming at me, "Why don't you check for the brackets then?" I answer, because with 18FB I also check if it's really a GZip and not some other type of compression or something completely different. Here I already started creating a function which is supposed to return true if the specified file is a GZip file. You notice that I opened the file using the with keyword instead of simply assigning the open function's return value to a variable. The with open statement requires all code accessing the file to be done in the following code block. Once the code block ends, it closes the file automatically. This is considered best practice because it prevents the developer from forgetting to close the open file. Leaving files open can cause a lot of problems like file lock and other sometimes very obscure and odd behavior. The open function returns a file object which gets stored in the variable f. Since f is now referring to a file object, I can access the methods defined for the file by using the dot operator like we've seen it before. Note that I opened the file using the mode RB, which stands for read binary. That makes sense because I'm expecting a compressed file of which I want to read the first 2 bytes. The read function takes an argument size specifying how many bytes to read, in my case 2. If I had opened the file in text mode, the size argument would depend on my system's encoding settings. I compare the 2 bytes with our magic numbers we learned from the GZip RFC. I can tell the Python interpreter that my string defines plain bytes with the prefix b. Hexadecimal values in the string are defined by escaping the x character followed by the value. I'm using the equality operator forming a Boolean expression, which is true in case my file starts with a magic number. And this is eventually the return value of my function. I define functions to read compressed, read uncompressed, and one which actually opens the material file. You see that this time I indeed specify the encoding because DAZ encodes their files UTF-8 to maintain Mac compatibility. We are reading a JSON file, right? Well, opening JSON files in Python is super easy. I import a JSON module and use the load function provided by this module. After that, my variable holds the complete content of the JSON file. Be aware that this is not a string. It's a data structure similar to the JSON file, but with Python entities I can easily access in Python code. Because I know my JSON encapsulates everything in an object, my function's return type is a dictionary. I'll get into that a little bit later, no worries. For the open compressed function, I import the GZip module, and in the open compressed function, I use the GZip module's open function to open the compressed file. Note that I open this in binary mode. The GZip module returns a file object, and using the read function, I store the content into the variable file_content. Because this is now uncompressed, but still a string, I convert it to the same data structure I used in the open_compressed function. Next I must code the open_material file function. I first check if it's compressed and then call the appropriate open function. And this concludes part 2 of editing DAZ Studio DSON files with a Python script. See you in the next part.